Hi everyone, in this video we're going to go over completing the square. Alright, but before we dive into the technique of completing the square, it's important to know what a perfect square is. So we're going to actually start describing what a perfect square is. So let's talk about that first. So what is a perfect square? So if you're taking a number, let's say 1, and you're squaring it, what you're doing is you're taking the number and you're multiplying it to itself. So 1 times 1 is 1. 2 to the square means 2 times 2, 4. 3 to the square means 3 times 3, and that's 9. And these numbers are perfect squares. Okay? Now, we can have the same scenario but with algebraic expressions. So x plus 1 to the square gives me x squared plus 2x plus 1. Now how do I do it that quickly? I'm actually applying this formula. A plus b to the square is a squared plus 2ab plus b squared. So it's the first number to the square plus 2 times the first number times the second number, and then plus the second number to the square. It's very important to actually know the formula because you can actually work it out quickly. Otherwise, you need to do the traditional way where x plus 1 to the square means x plus 1 times x plus 1, and you're doing it one at a time, which takes more time because I'll need to do x times x squared, x times 1, x, 1 times x, 1 times 1, 1. And then you add all of that, you get x squared plus 2x plus 1, which takes more time. And you can compare these two here, and you realize that here I'm just doing it in one line. All right. And in the same way, if I do x plus 2 to the square, it's x to the square plus, look at how my brain actually processes that. So I'll take the first term, square it, plus 2 times x times 2, that's 4x, plus 2 to the square, that's 4. Okay, so I'm constantly using this formula to actually get those. And these are also perfect squares, but we're just dealing with algebra. Okay, and why am I actually involving algebra also in it? It's because we actually will need to think along those lines when we try to complete the square. All right. So let's see how equation looks like now. So let's go back to the workbook. So that workbook is on the website. It's from the IGCSE syllabus. It's about algebraic manipulation. All right. So it has a section on completing the square here. So it tells you that when you finish completing the square to an expression, you end up getting a form like that. Okay, where you have x plus a constant to the square. That number a can actually be a fraction also in some cases. So x plus a to the square plus b. Now the b also can be negative, so it's not that it's always a positive number here. Now the example in the workbook here is an example whereby the coefficient of x squared is not 1. So first of all, I'm going to do one for you whereby the coefficient of x squared is indeed 1 before we move to a more complex one. So let's just do one where the coefficient of x squared is 1. So let's say I need to, okay, before I actually give you an example, let's say you had x squared plus 2x plus 1. You need to realize that this comes from x plus 1 to the square. Okay? Because this is this. We use completing the square when actually it's not a perfect square. So I'm going to give you an example. So let's say, so example 1 is x squared plus 2x plus 4. So this is not a perfect square because you can't expand x plus a number to the square and actually get this. So you'll need to realize that x squared plus 2x, the plus 2x actually comes from x plus 1 to the square, because when I expand x plus 1 to the square, I get x squared plus 2x plus 1. Okay, so what I do is the x squared plus 2x plus 4, I write it as this expression, which comes from x plus 1 to the square, and then plus 3. Why do I do that? Because 1 plus 3 actually gives me 4. So this expression I just wrote here is an alternate version of the question which they gave us. But why am I writing in this form? It's because I know that when I see a 2x, the perfect square is actually x plus 1 to the square. So x plus 1 to the square gives me x squared plus 2x plus 1. So I write it, the perfect square, and then I manipulate the expression in such a way that I end up getting the original question. And when you do that, you already know that this is x plus 1 to the square. So you replace that expression by x plus 1 to the square, and then it's plus 3. Okay? So this is what we do, and this is why it's important you actually know your expansion, so that you know in advance that, okay, here I need to use x squared plus 2x plus 1. Let me show you another one. So let's say I have x squared plus 2x plus 5. Once again, I see 2x, so I know that I need to use x squared plus 2x plus 1, because this is from x plus 1 to the square. So which manipulation do I need to do here? I need to get plus 5, so I need to have a plus 4 here. So I do that, and then the x squared plus 2x plus 1 is actually x plus 1 to the square. So this is what I get after completing the square. All right. Let us look at the question where the coefficient of x squared was not 1 now. So this one, 3x squared plus 12x plus 9. So let us try this one. So 3x squared plus 12x plus 9. So when I have an expression whereby the coefficient of x squared is not 1, what I need to do is I need to actually make it become 1. Now, I can't divide by 3 here to make the coefficient of x squared become 1, because I'm actually changing the question if I divide each term by 3. So what I do is I factorize the 3 out, and then I get x squared plus 4x plus 3. And I check whether I'm getting the original equation when I expand. 3 times x squared, 3x squared, 3 times 4x, 12x, 3 times 3, 9. If you have difficulties factorizing, then you actually need to go at the start of the worksheet, whereby we have a section about factorization, and you need to practice that first, mastered, before you actually move to that kind of algebraic manipulation, which we're doing right now. So I factorize the 3 first, and then I now work with what's inside the bracket. Now, in the expression here, I see x squared plus 4x. So when do I get 4x? I get a 4x when I'm actually expanding x plus 2 to the square. Because you see, that's where I get 4x. So I need to know that here I'll need to use x plus 2 to the square, which is x squared plus 4x plus 4. All right? However, once we've written that here, we can see that we need to get plus 3, but I have a plus 4. So the manipulation we need to do here is we need to subtract 1. So then you get 3, open bracket, x squared plus 4x plus 4 is actually x plus 2 to the square. So it's x plus 2 to the square minus 1. And then if you expand that, you get 3x plus 2 to the square. And then 3 times minus 1 is minus 3. So that will be the final answer you get after completing the square. All right. There is an alternate version to completing the square if you don't quite like this way of working it out, but we can explore that in another video. All right. So I hope that you were able to look at all the different steps and really understand the reasoning behind each manipulation we're doing. And good luck with that.